that's now our slogan, shortest path to better software, and that will become apparent here in a little bit. This is, as you get into DevOps, this is what people have been saying since before DevOps was a thing. Every company is a software company now. I don't care if you're Chevron, if you are Gap, if you are, well, NASA is a little more apparent, but everybody, their core operations, whether it's, no matter what vertical you're in, is based on the quality of software that the operations can deliver. And that's pretty much why we're here. How can we deliver better services to the business? And it's not just saying that, hey, I have encapsulated this perfect server, this perfect service here in time, because change is necessary. You know, you might be able to get away in some organizations to say that, hey, I have this golden image. Whenever I want to deploy a new database server, a new application server, just going to throw out this golden image because nothing will ever change. Nobody lives in that world. I wish we did. I'd be able to go home and golf every weekend, but that is not the case. So this is why I'm here. This is sort of my elevator pitch as I talk to different organizations at different levels. You know, if I'm talking to a VP or CTO, I don't generally like to get into the weeds with them. So this is how I position Puppet. Puppet is essentially a modeling framework. You are building a model of how you expect your infrastructure to behave. And everything goes into that model, whether it's your security requirements, the actual configuration, how different pieces speak to each other. You build everything into that model, and then Puppet manages against that model. It will continually compare the server against the model to see if there's any non-compliant configurations, and it'll remediate it from there. And this is just sort of restating that, you know, ultimately, since I am now working sort of in the federal space, this is, I hammer this into everybody, is everything goes into that model. And once you have a stable, secure model that you're happy with, you get that full transparency chain to what is going on with your infrastructure. Since Puppet is continually monitoring against and remediating against that model, you know when changes are happening, you know that any non-compliant changes that are happening will get remediated and reported on, and you have this sort of framework for making changes in a sane way to your infrastructure. It really becomes sort of a change management framework as well. So how do we do that? There's really, actually I think two of these are kind of redundant. I didn't make all these slides. So we define with a common language, that is our modeling language, the Puppet DSL, which I'll show you here in a little bit. Gain situational awareness, which kind of segues into ensure security and compliance, is really about that transparency. How good a view do you have into change within your infrastructure? How much information do you have, and is that information actionable? And then finally, which is actually something that's fairly new for some of you that may have been using Puppet for a little while, is orchestrating change intelligently. Being able to model the relationships between different servers and services within your organization, so you can deploy change, widespread change in a more sane way as well. So let's start with defining with a common language. Can everybody see everything okay here? Great. This is just a small snippet of Puppet code, what we call the Puppet DSL. If you are used to Nagios monitoring files, something along those lines, it should be fairly familiar to you. They're just essentially resources with metadata associated with them. So in this case, we're managing a Red Hat firewall. So we want to make sure that IP tables is running at all times. We want to make sure if that server were to restart, that the service would actually start with it, and then out at the bottom it's actually saying that the IP tables package should be installed. So this is, again, we're modeling, we're defining against end state. Puppet will continually compare the state to this sort of model that you've built, and if there's any deviation, it will remediate to that. And that becomes something to think about, because you're not thinking necessarily about, I need to deploy an application. These are all the states that this is all the actions I need to take to deploy an application or to provision a new server. What you're doing is you're thinking about what is the ultimate role? What is that ultimate state of a server that we expect it to be behaving in? And then we build that. It's almost like building something with Legos. You're building towards that end state. Gaining situational awareness via the console and some of the APIs that we provide. You get a history of all changes that you're managing within your infrastructure. So anytime that Puppet sees a server or a service that deviates from this sort of canonical model that you're building, Puppet will remediate that, it will report on it, and there's a myriad of different ways in which you can consume your reports. So, if you come in on a Monday morning, you want to see how your infrastructure behaved over the weekend, you have, again, that full transparency change there. Orchestrating change intelligently. I'm actually going to dive into this a little bit later. So let me actually skip this for right now. And then ensuring security and compliance. Once you have your security regulations, your sort of the mandate from the business to say that, hey, we want to make sure that we're conforming to whatever standard that you have to conform to, auditing actually at that point becomes easy. Where anytime, again, if it deviates from the model, Puppet will report onto it. So what certain organizations will actually do, I know Google does this, is they actually took the security scanning scripts that their security apparatus had been using for them, and they rewrote those into Puppet code. And so they then trained their internal auditing team how to read the Puppet code. So you have this sort of definition of how you expect your infrastructure to behave. The auditors, it's usually very human readable. The auditors can say, hey, we're comfortable with this definition or not. And if they are, they now have the ability to log into the console to consume those reports, so they can spot check anytime that they want. They can wake up at 3 o'clock in the morning and say, hey, I want to make sure that random server is in compliance, and they now have the ability to do that. This, I think, that second sentence is really where you're seeing Puppet going. It has been a big push for us. With application orchestration, we started giving you the ability to model the relationships between different pieces of your infrastructure. So that may be, database servers and application servers, but that may also be switches. That may also be storage devices. That may also be load balancers. So ultimately, to be able to model the state of multi-tier applications, complex applications, we need the ability to interact with every piece of the stack. And so that's how we get to, if it has an API, if it has an IP address, we want Puppet to be able to manage it. And this is just a few examples of different partners that we have in this space. I heard that Kubernetes were out here a few weeks ago. Amazon Web Services, Azure, Red Hat, F5 load balancers, Cisco. So ultimately, we want you to be able to model every piece of your environment with Puppet. Oh, I went backwards. And that's every piece of the stack itself. We sort of, for those of you who have been using Puppet since 0.6 and 2.7, you probably know, at the beginning, everybody started with the core infrastructure. Managing SSH, managing firewalls, users groups, things along those lines. But as we matured more and more, we creeped up the stack to the application infrastructure, your databases, your application servers, up through provisioning, now with our integrations with Amazon, Azure, Docker, into full application orchestration, which again, I'll show you here in a little bit. So how does this actually happen? How does this work? And you're actually getting a peek into some functionality that actually came out less than 2 weeks ago. So this right here is sort of how Puppet has classically worked. Puppet is an agent-master relationship. It's a pull-based relationship. So every server has an agent, and by default, every half hour will wake up and essentially ask, what should my configuration be? And it's going to collect a set of information about itself. What kernel version am I running? How much RAM do I have? Hard drive space? What's my IP address? Things along those lines. And I'll send those, what we call facts, up to the Puppet master. And in combination with its classification, basically have you determine that a particular server should be a database server, a web server, what have you. The Puppet master then has enough information to compile what we call the catalog. And that catalog is that machine readable sort of canonical model that gets sent down, and then it will it can simulate against it, it can enforce against it, generate a report, and give you that full transparency chain that we were talking about. What we've changed and what we're now calling direct Puppet is, at first, when you're first deploying a new server, it looks exactly the same way. Generate facts, send them up to the master, you receive a catalog, you have your model. But it will then cache that catalog. It'll cache the last known good state. So it will continually manage against that cache catalog. And what that gives you the ability to do is, at this point, it's not asking for a new catalog from the Puppet Master every half hour. So you're able to accomplish much more scale. Essentially what we're doing here is we're separating the idea of state management from change management. Because once you say that, hey, I have this sort of canonical model, I want to make an update to that model, we use direct mode to say that, hey, I've made an update to my Puppet code, it's gone through testing, it's now ready to deploy out to my servers. It now sends a message out saying, hey, for you servers, I want you to generate a new catalog and then enforce against that. And so as it is right now, you're still having to worry about, again, I don't want to get too far in the weeds because I know most of you aren't currently using Puppet, but at this point you're scaling against peak load. Because if you're deploying a change across all your servers, then all your servers are going to be asking for a new catalog, and it's going to generate a good bit of load there. But in the future, we're going to have the ability to pre-compile catalogs. So you can ask the Puppet Master to say that, hey, for all the nodes that match these facts, I want you to go ahead and pre-compile a catalog, and then I'll tell you when to send it out. So it takes away those sort of peaks from the load on the Puppet Master. As of right now, I think our largest commercial customer who's using this has gotten it to scale to, I think they have 100,000 servers right now, and they're looking at 150,000 servers by the end of the year. And I already discussed all that. So let's get into application orchestration, which I think is one of the coolest things that we've done in a while. So kind of from the beginning, and I'm going to be a little biased here, I work for Puppet, but we consider ourselves sort of best in class as far as managing the state and the dependencies within a particular server. So if you want to build a MS SQL server, we can do that from here to kingdom come, do it 1,000 times, it will get done. And so, like I said, MS SQL server, really good at doing that. Building a web service on AIX, we're really good at doing that. Configuring servers within the load balancer, really good at doing that. But up until last winter, it was kind of piecemeal. You had to manage yourself, and this is why sometimes people would use something like Ansible with Puppet, is you would have to have an upper layer of orchestration to handle, well, if all these servers are going to be talking to each other, I need to make sure that the database server is able to talk to the web server, and the web server is able to talk to the load balancer. But with application orchestration, we've expanded our kind of layer of abstraction to say the language can now define the relationships between the servers. So I know when I'm building MS SQL, it's going to be listening on a particular port, exposing a particular database for particular credentials, which then can be consumed by my application server, which will then do the same to the load balancer. So again, you're able to model all the relationships between servers, and the application service is actually aware of those dependencies. So I'll actually demonstrate that in a couple minutes. Since I have been here for 2.5 years, occasionally they come up and say that, hey, we have found internally a possible exploit, but I have never heard of anybody hacking Puppet itself. So we have our puppet.com/security. We conform to coordinated disclosure, so you can actually go out and see all the CVEs that people have opened against Puppet Enterprise. It's actually Puppet and Puppet Enterprise and Puppet Open Source, as well as when they were resolved. So we are very transparent about security concerns that come up across Puppet. In fact, I wrote a document this morning for a customer that was sort of concerned about the same thing: is what are our best practices for actually securing the Puppet master, the Puppet infrastructure itself. And if we want to have that discussion, we can do that. So this is the Puppet Enterprise console. This sort of update in the GUI is that we rolled this out last winter. And this is sort of your one-stop shop to do a few things. To consume reports, to perform the classification, actually assign roles to particular servers, as well as handle access management, being able to determine which group of engineers have access to which servers at which level. So since I was talking about application orchestration, let's do a little bit of that. So I have this group that has the ability to deploy to different environments. And I want to make sure that this actually does what I think it does. Perfect. This is all backed by, you can actually use the Puppet database to handle your own user management, but you can also back what we call the role-based access control with your own directory services, like OpenLDAP, Active Directory, something like that. But as of right now, I'm just doing this manually. So I given one particular user the ability to deploy code. And there's also an API for all this. So what I can do is say, I'm going to request a token. And if I did that right, hooray. Don't mind some of this. So now I have access to the command line tools to see which applications that this particular user has access to. And apparently I set this up wrong. There we go. So now I see I have two different applications. Actually, it's the same application in two different environments that this user has the ability to deploy changes to. We have RGBank Dev. This is just a simple WordPress application that is sort of a sample banking app. So in the dev environment, we have all the different pieces. You can sort of see how we define some of the dependencies between the database, the web server, and the load balancer. But in the development environment, it's all running on one server, where within the staging environment, we actually have all these different pieces running on different servers. So we actually have the ability now to, let's go ahead and let's say, do an orchestration out in the dev environment. So like I said, we have defined all the dependencies between the different pieces here. The orchestration tool is aware of those dependencies, and it has the ability to deploy the different pieces in the right order. Whether it's on one server, as we're doing right now, or on a half a dozen different servers is what we do in the, for the staging version of this application. So we now have 41 changes. We should be able to actually hit this guy. Have a nice WordPress application. There we go. We now have our fancy schmancy banking application. And when I talk about having the visibility and transparency into what actually happened here, that went actually off without a hitch, but we can actually dive into the the reporting here and see exactly what Puppet did to accomplish that. So again, you have full visibility into what changes are happening, when those changes are happening, how things are differing in a live server than the way that you expect it to. And what's also nice about this is you actually have the ability to sort of aggregate that. So if you came in, like I said, you came in on Monday morning and you wanted to see, hey, what happened over the weekend, you have the ability to aggregate, create a report to see that, hey, we had, over the past 24 hours, we had 2 nodes that had changes and 2 nodes that had failures on the node. Puppet was not able to enforce the compliant state on that server for whatever reason. So you're able to have a much more holistic view into the health of your environment that way.